Hi children, good morning. Welcome back to our session. Are you watching the videos children? Any doubts? You can clarify with us, and whatever we are note down in the points on the blackboard, you have to maintain your running notes, because be careful, you are in 10th standard. Okay? So today's what is our topic? Light, reflection and refraction. So yesterday's previous classes we have learnt about the reflection of light. Today's session we are going to know about the refraction of light. Refraction of light. Reflection of light, bouncing of the light. Refraction of light, it is the bending towards of the light. Let me see. Refraction of light is the phenomenon to change the path of the light is going from one medium to another. So what will happen if it is going towards to one media to the another medium? It is going to change the path of the light. Is it? Yes. So in going from a rarer to denser. So here two mediums we are having, that is rarer medium and as well as denser medium. Rarer to denser medium, the ray of light bends towards normal, and in going from denser to the rarer medium, the ray of light bends away from the normal. So from one media to another media, when it is going to bend, we are going to see the changes in that. So that is bends away from the normal. We will see that it is going to bend, which is to the normal. Comparing to the normal, we can see when it is going from one media to another media, it is going to bend. This bending by refraction makes it possible for us to have lenses, magnifying glasses, prism, rainbows. So we can see this bending of the refraction, mainly the lenses, magnifying glasses, prisms and rainbows. Is it? Yes. So this is about the refraction. Now let me see the refraction through a rectangular glass slab. Before this, I will explain with a small activity, children. Take a beaker. Yes, gas beaker. So in this, take half of the beaker filled with water. Then take a pencil or a scale or a spoon or a stick, whatever may be, and dip it into the water. So what we can observe means, here see, if I take a pencil up to the water level, it is in the normal position. When we are dipped into the water, here we can see the change. That means here a small bending towards, also we can see here, bend. And see the size, it is somewhat increase of the size. Why? Because this is called as the rarer medium. Then this is the water is called as the denser medium. So when the object will enter from the rarer medium to the denser medium, there exactly we can see that bend of that object, and we can observe the size of that object also will be increased. When we take it out, it will be in the normal position. Not only that, take a beaker and the same thing, fill with water, half of this, and in this you can keep a coin also, children. So if you dip a coin inside, the coin will be actually this much size. If you dip it inside, we will see that the size of the coin has increased, and also little bit it will be floating. Because of that, the same thing, this is the rarer medium and this is the denser medium. When it enters to the rarer medium to the denser medium, we can see that the size of that object also it is increased. For example, you can observe in the shops also. In front of the shop, in a glass, they used to keep the lemon. That for something, they'll say drishti, that and this. But we don't want. What is that science concept? It looks like the big in size. So, small lemon which was like a big orange one. Is it? Why? Because which phenomena? That is nothing but the refraction of the light. So, this is the example for the refraction of the light. Now, let us go to the topic is refraction through the rectangular glass slab. I'll show through a video of the explanation of this activity. You also should be carefully take the things and try to draw it. Okay? Thank you.
Perform an experiment of refraction through glass slab, and for that we require a glass slab, scale, eraser, pencil, protector and few pins. These pins must easily actually penetrate inside the wooden board. So we also have the wooden board on which I have kept the A4 size paper. Now how we are going to start the experiment is, we are going to take two pins and then we are going to put the glass slab at the center, and two softboard pins must be rigidly fixed like this so that the paper does not move, one on each of the opposite sides. So you can see that I have fixed it. Now try to minimize the movement of the entire apparatus. Now what am I going to do is, I am going to make the outline, mark the outline. Okay, so here is the outline of our glass slab. Now with the help of protector, keep the protector exactly in between like this, and I need to draw an angle of 60 degree with the normal. So I'll be marking a point here, and this part of the protector I am going to keep it over here, and this line should be coinciding with the line which we have made, the outline of the glass slab, like this. Now this would be normal, so this point would be the normal, and from here this is 10 degree, 20 degree, 30 degree. So I am going to keep the angle of incidence 30 degree. Now with the scale, don't get confused, this is not 60 degree. We are measuring the angles from here, 10, 20, 30. Now I am going to remove this, and with the scale, this would be my normal, and joining these two, this is my incident ray, right? Okay, now what am I going to do is, I am going to extend this line forward, like this. Now this angle is the angle of incidence, and we know that this is 30 degree. Now what am I going to do is, I am going to put back the glass slab like this, properly placed. Now I will be needing another 4 softboard pins, and I am going to attach them on this incident ray. Okay, now from this side, I mean to say that from this side I'll see these 2 softboard pins from here. So by keeping one eye closed, I am going to keep my eye over here and observe these 2 softboard pins from this side, and I will keep another 2 softboard pins here in such a way that all 4 appear to be in straight line. So these two softboard pins I am supposed to put it over here, and I'll have to keep one of my eyes closed, and I'll have to put these two softboard pins in such a way that all four are in a straight line. So I'll do that, and by keeping one eye closed, this is the one, and okay, this is the one. Fine. Now I kept my eye over here, and I had fixed another two pins, and for me that from this side it was appearing as if all four are in straight line. Let me try to show you this. So you can see that all four pins are appearing in a straight line, right guys? Okay. Now I need to remove these pins, and with the help of this pencil I'll mark these 2 points. Now we don't require this glass slab, so I'll put it aside. Be very careful in handling the glass slabs because fragile material. Now with the help of scale I am going to make a straight line in such a way that these two dots are joining my out marking over here, like this. This would be my refracted ray. This is the point of incidence. Again a normal. Now this point and this point are supposed to be connected like this, right? Okay, so you can see that this ray of light was coming from air to the glass, so it bent towards the normal. Now this light ray was going from the glass to the air, so it is bending away from the normal. Now this extended ray, this ray I need to extend it, and you can see that the extended ray was not up to the mark, so I am extending this once again, and you can see that the refracted ray and the extended incident ray are parallel. Now this distance is called the lateral shift. Let me measure the lateral shift. The lateral shift is 1.3 centimeters. So the value of lateral shift was 1.3 centimeters, and now I can also measure the angle of refraction as well. So the angle of refraction would be this angle, and very carefully we are supposed to measure this angle. So here is the point where I am going to put this point of my protector like this, and this line should be matching with my normal. So okay, now this angle is 20 degree. You can see that, right? So this angle is 20 degree, and now I am getting this angle as 20 degree. So this is the way in which we measure the angle of incidence, angle of refraction, and the angle of emergence would be same as the angle of incidence. Let's check that again. So this point, I am going to put this point over here. You can see that it is almost 30 degree. I made a mistake because of some kind of errors. It is turning 28, right? So my experimental answer is 28 degrees, so it should be 2 degree more than what I should expect. So this is the experiment about the refraction through glass slab.